Good morning, teacher. My name is Fernando Rivera, and also with me are my partners Rodrigo, Ibarra, Romero, and Yahir Medina de Santiago. We are the team called Aiot, and our project is a build conveyor. So let's start with the presentation of the project. The first thing is the introduction. Well, a conveyor belt with speed control and direction control of the belt will be made. A graphical interface will be used through LabVIEW software to visualize the band. The project consists of 3 digital inputs, 3 digital outputs, 1 output input, and 1 analog output. A PWM, that is a pulse width modulation control, will be used to control the speed of a belt motor. An Arduino Uno is going to be used as a microcontroller of the conveyor. Also, it will serve as a data acquisition card. After we have the development, here we have all the inputs and outputs that will be used in the project. As input, we have the push buttons and the sensor HR0062, that is a proximity sensor, and the quantity are 3 push buttons and 1 sensor of proximity. And the Arduino pins for the push buttons will be the pin 2, the pin 3, and the pin 4. And for the sensor and for the proximity sensor will be used the pin number 12. And then we have the outputs. We are going to have as outputs the LEDs and the driver L298N. The quantity is going to be 3 LEDs, and the Arduino pins are the 9, the 10, and the pin 11. And for the driver, it's going to be the pin number 6, the number 7, and the number 8. Then I'm going to explain the use for each object. The first one is the push buttons. Push button is a 4-pin momentary switch used as a signal input to select the direction of rotation of the belt. And then we have the proximity sensor HR0062. That is a 3-pin infrared sensor that will be used to register the presence of an object, and in this way to quantify the units. Then we have the LEDs, that a LED is a light emitting diode. It can be used as a digital output to indicate physically the sense of an object. The LEDs will be used to indicate when an object is detected by the proximity sensor. And finally, we have the driver L298N. This driver is a dual H bridge that allows control of spin and speed of 2 DC motors or a bipolar stepper motor.
Okay, we have one analog input and one analog output. Okay, the analog input is a pot, and this is in the pin A0 of the Arduino, and the analog output is in the PWM in the pin 6 of the Arduino. Okay. The pod can make values of the 0 from 0 to 123. Okay, with this, I make modulation with the output of the PWM. Okay, with the modulation of the pulse of the PWM, I can control the speed of the motor. Okay, if the duty cycle is small, the RPM of the motor is low. If the duty cycle is high, the RPM of the motor is it's high. It speeds quickly. Okay. The diagram of the electrical diagram of the connection it's first okay, first is the Arduino. The Arduino, we have two wires to connect it to a proto board, the power supply to the proto board to power all the circuit. Okay. We use the three buttons, three LEDs, the pot, the sensor in the proto board. Okay, and we use three wires to control the driver motors, and we use the motor. This is the power supply of the motor. This is the power supply of the motors, positive and negative. Okay.
Well, here we can see the front panel of the program, the view, and we have three LEDs, three LEDs and three buttons. This LED and this button is for the stop of the motor. This LED and this button is for the left turn, and this is for the right turn. We can see the buttons of the potentiometer. We have our serial port and the RPM of the motor. We can see also a little interface for the sensor. This sensor detects the objects that are passing by the conveyor belt, and it counts how many has passed. Now this is the block diagram. We have three case structures. One, these three are for the stop, right and left turn that we see here. It has some security, so it doesn't, so the motor doesn't broke. And we here, let me do some. Here we see the analog read for the potentiometer, that it turns to be from 0 to 100. Now this is the cycle for the sensor, and every time it detects something, it counts 1 to the counter. And this is the user interface on physics. It is the same as that our front panel, but we have all in physics. So if something in the program doesn't work, we have this. We can control the left turn, the stop, the right turn, and here it's the potentiometer that controls the velocity of the motor spin. Here we have our Arduino and our connections. Here is the sensor, the three LEDs, the potentiometer, and our driver. Now, here, in conclusion, well, at the end, we realized that the conveyor belt here didn't work because the sandpaper and the sandpaper didn't grab too well the fabric, because the fabric was very thin, as well as the sandpaper. So we changed to a thicker sandpaper. Here we can see, because it's under the name, and the fabric we changed to denim, so it grabs better. And with those change, the conveyor belt works perfect.